So we're going to kind of jump into lesson 10.2 and talk about simplifying radical expressions. And today's date is 5/6. So a radical expression, make sure we understand what that is. Is an expression, so there's no equal sign, that contains a square root symbol. And I'm going to write in parentheses, that means the same as a radical sign. Okay. Now, there are some rules about simplifying radical expressions. Okay. Now, remember we talked about this a while back, that this number here is called the radicand. I'm going to color it different here. This is called the radical sign. And do you guys remember what number goes here, what it's called? Same name as the cards that you get that are 3x5, blank on one side, lines on the other. No, it's not what they're called. They're called index cards. So this is your index. So the index is the one that determines what root you're taking it to. So if our index, so that little crook, is empty, that means it's a square root. If there's a 3, it's a cube root. If it's a 15, it's a 15th root. Okay, so it tells us what we're looking for. Okay, so these are some rules that must be followed in order for an answer to be simplified. Okay, so let's say a radical is in simplest radical form SRF if, and we have several things that we need. One, and this is the one that you guys were really practicing last night. No radicands have perfect square factors other than 1. So I can leave a 1 under the radical sign and I'm okay. So if 2 has only the factors 2 times 1, neither one of them are perfect square. Well, 1's a perfect square, 2 isn't. I exclude 1 because if I take the square root of 1, I get 1 and it doesn't change anything. Okay, so that's rule number 1. Rule number 2. No radicands can be fractions. Now, I'm just going to give you all the rules. We're not going to see these in our math. Number 1 rule is the one that we're going to focus in on. So if I have a square root of 2/3, there's more I'm going to have to do. Again, you're going to get more of that later on. Okay. Last rule. No radical signs may be in a denominator. Okay, so the only rule that we're focusing in on is rule number 1. Rule 2 and 3 are what are going to show up in your Algebra 2 class. Okay, so let's focus in on rule number 1, and that's what that sheet was all about. Okay, everybody good? So in that sheet that I gave you, it mentioned a property that's extremely important, and so we're going to talk about that one, and that is the product property of square roots. So we're going to talk about it in words, and then we'll talk about it also in symbol. And it basically says the square root of a product AB, so they just are giving you a generic product, is the same as the product of radical A times radical B. Okay. Now I changed the words from square root to radical. Those are interchangeable. Radical and square root mean the same thing. Okay. So in symbols it would look like this. This is a product. Now, we wouldn't see it as being two numbers next to each other. We would see it as 24, a number, okay? So then we could break it down into the factors of our number, okay? Is there an issue? Okay, guys, hello, come back, okay? So what we're looking for is you need to find perfect square factors of your radicand. So you're not looking for 2s and 3s and 5s, 6s. You're looking for 4s and 9s and 25s and 16s. Those are what you're looking for, okay? You're not looking for divisibility rules. You're looking for perfect square factors. That's the key here, okay? Now, what did you guys learn about what type of variables can you take the square root of? So we're going to write that down too. Okay, so a variable with an even exponent is a perfect square. What did we mathematically do when I took the square root of a variable with an even exponent to get it to come outside? What happened to the exponent of that original variable when I took its square root? So I had x to the 4th. If I took the square root of x to the 4th, what did I get? I got x squared. If I had x to the 6th power, what's the square root of x to the 6th? X cubed. So I went from 4 to 2. I went from 6 to 3. So what am I doing to my exponent when I take its square root? I'm dividing by 2. So a variable with an even exponent is a perfect square. To take its square root,
was it supposed to rain today?
yes, you will take half of the exponent. According to my phone, it's off and on throughout the whole day. There's a 40 to 50% chance of rain pretty much every hour. Okay. So to take its square root, take half of the exponent. And the reason for that is the square root of a value is, let's say we'll put it like this, is the same as raising that radicand to the half power. The index is 2. The exponent on the variable x was 1. That's where the 1/2 comes from. So a square root symbol is the same as taking something to the half power. That's why we take half of the exponent when we take a square root of a variable. Okay? So let's go through some examples, and that'll be it for this. So directions are going to ask you to, see, what do they say? Simplify. Simplify means do all the math that you can do until there's no more math to be done. So let's start with square root of 80. So again, what I'm looking for are perfect squares that go into 80. So what do you know can divide evenly into 80 that's a perfect square? Pardon me? Neither one of those are perfect squares. 4 can go in. So I'm going to use that product property of radicals and say square root of 80 is the same thing as the square root of 4 times the square root of 20. So does 20 have any perfect squares? It has another 4. So I have a square root of 4 for the first one, and then 20 breaks into 2 squares, or square roots. Square root of 4 times the square root of 5. Can I break 5 down? No. So what I do is I just do what I can. What's the square root of 4? What's the square root of 4? What's the square root of 5? Square root of 5. Now I'm left with a product on the outside. What's 2 times 2? 4. So actually, what was the greatest perfect square of 80? So actually, the greatest perfect square was 16. So again, we got there to the end, and that's the bottom line. How we get there may be different vehicles. But if we're starting with non-perfect squares, then we're going to have to match up. Oh, this leftover 2 can go with this leftover 2 and make a 4. So that's why I always want you to think of what are the greatest perfect squares that I can pull out, or any perfect square. Michael? It's outside. There's no radical sign. Once I take a square root of a number, the radical sign is gone. So we don't continue on unless it's under a radical sign, okay? All right, let's do another one. You saw some like this on your homework. Where the problem looked like this. Well, this is still, we can use the product property of square roots kind of in a reverse fashion. What we can do is say this is the same as the square root of 2 times 14. So then we say, well, that's just the square root of 28. Now what we can do is look for the perfect square factor of 28. What's the perfect square factor? 4. So we've got the square root of 4, and its partner factor is 7. And then the square root of 4 is 2, and we can't take the square root of 7, and that's our answer. Forgot to box this guy. Okay? So when you have 2 radicals being multiplied, or if you have a radical, we're still using the product property of square roots, but just in different ways. It's kind of like doing distributive property and factoring, which are both distributive property, but it's just looking at it from different ways. All right, so let's add with variables. Oops, I think I went too far. No, I'm good. Okay, so let's do one that has variables. Oops, that's supposed to be a 90. So we have 90x cubed, y to the 4th, z to the 5th. Okay? Because what we talked about with variables is if they have an even exponent, they're perfect squares and we can take the square roots. But what we haven't talked about is what if it's an odd exponent? Okay, so that's what we're going to contend with in this one. So let's look at the 90. What is the greatest perfect square of 90? 9. So we're going to split 90 into the square root of 9 times the square root of 10. Now, what's the greatest perfect square exponent I can have on x if I have x cubed? Yes, the most number of x's that I can pull out that would be even would be x squared. And then we have a leftover x. Okay, guess what? Y to the 4th is already a perfect square, so I just leave him alone. And how am I going to split that z to the 5th? What's the largest even exponent I can pull out of him? Yeah. So every time I have an odd exponent, all I'm going to do is pull out one value. So I know that's kind of rude to do that. So z to the 5th becomes z to the 4th times, or square root of z to the 5th becomes the square root of z to the 4th times the square root of z. So if I pull out 1 from the odd exponent, I'm left with the largest even exponent. All right, so what I'm going to do is circle up all my perfect squares. And I'm going to take all of their square roots. So let's see, I get square root of 9 is 3. Square root of x squared, half of 2 is 1, so I get x. Square root of y to the 4th, half of 4 is 2, so I get y squared. Half of 4 is 2, so I get z squared. And then what I'm going to do is put all the remainders under a radical sign. So we got the square root of 10x z, and that would be my answer. Okay? Now there's multiple ways how you can show this work. I'm just breaking it down piece by piece so you can see it. So let's do another one like that, because that's definitely the hardest of them. So we have 56x y to the 10th z to the 5th. All right, so now I'm looking for greatest perfect square factors of 56. What do you think we could split that? What's a perfect square that could go into 56? 4. And 4 goes into 5 once with 1 left over, and it goes into 16 4 times. Can I find... 9 doesn't go in. The digits add up to 11, so 3 can't go in, so 9 can't go in. So can I break 14 into a perfect square times a non-perfect square? And the answer is no, 2 and 7 are not perfect squares. So I actually can't do anything more with the square root of 14. So that's the best I could do. Square root of x is odd, so he just stays that. We do have an even on the y to the 10th, so he stays as y to the 10th. And how do I split the z to the 5th? Z to the 4th and a z. So, again, I'm going to circle up all of my perfect squares, and I'm going to take their square roots. So the square root of 4 is 2. The square root of y to the 10th, half of 10 is 5, so I get y to the 5th. Z to the 4th, square root of that, half of 4 is 2, so I get z squared. And then I'm going to take all of the leftovers, and they can form their own little pity party. And they get 14xz. And that's the answer to that one. Okay? Now, here's the good news. What you are going to be contending with in our work is only going to be the numerical ones. So the first example that I gave you, or the first 2 that I gave you, that may be the only thing that you contend with in all the stuff that we deal with, okay? So I'm going to find you a couple of problems to do off of this page, but I do want to talk about the next lesson in our Chapter 9.